All right, welcome to the very rare lunchtime video. I'm going to turn up the volume. I was watching my old videos and the volume was a bit low on them. Kind of surprised because my audio, if I show what I'm looking at here, I'm looking at this down here, my audio capture input, and it's going into the red like often. So like I used to have it like down here. Um, to keep it at the high end of the green and stay out of the yellow. But going back and listening to my videos, that was actually way too quiet. So I think I'm gonna aim so that it's like in the middle of the yellow. So I'll keep it like right here. And of course, I talk at much different levels, but I want to keep it like in this area instead of this area for this video and see if it's any better from the previous video. Okay, so for this video, it's going to be same thing as the last video. We're gonna do a quick diversion here into trying to fill in any gaps in my knowledge when it comes to Git and GitHub. And anyone on this channel who's even an advanced network engineer who's never seen this before, introducing it to them for the first time. So let me go ahead and pull up my lab that I'm working on for this. Okay, so it's this one here, flask-by-example. All right. Last video we learned about head. I gave kind of a explanation about what a head was. That was completely false. I said that the head was the same as the SHA hashes. The head is quite a bit different. In fact, it's different than the SHA hashes. To say that the head is the same as the SHA hashes is just wrong. One of the ways you can think about what a head is by thinking about a record player, which a lot of people, if you're younger, you might have never seen a record player before. But I mean, you can look up images, like a phonograph, something like that. So the head is going to be this part here, where you put it in the grooves, and then on each of the grooves, you have like a song that plays, or however, so. I was thinking that like each of the songs, the grooves was the head, but no, there's only one head. So you can't have multiple heads. So I think this is really the way to think of it is like a turntable with the head being the part of the turntable that goes into the grooves of the disk. And then each groove of the disk, those are the SHA hashes. That's the proper way to think of it, in my opinion. And I was thinking about this earlier, like Linus Torvalds, yeah, the Finnish software engineer who invented Linux. He's 51 years old, born in 1967. So when he was 10 years old, that would be 1979, 20-year-old, 1989. So when were record players popular? If we look at this, they became extremely popular in the 50s and 60s. So undoubtedly, he probably had a record player in his house when he was growing up. I had one. I was born in about 20 years after him. I didn't really use it much or at all, but there was always a record, leftover junk from my parents, including a record player. I think they still have it. So undoubtedly, a lot of these concepts probably were developed from knowledge of record players. That's probably why it's called a head and where that whole concept comes from. And then to this day, mechanical hard drives. If you look up, if you take apart your mechanical hard drive, and you look inside of it, you're basically just going to see a record player. But of course, it's really advanced. But yeah, we can see this looks the exact same as a turntable essentially, but with more shiny disk, less apparent grooves. Um, so I think that's probably the best way analogy to think of when you're learning these concepts is kind of like a record player, because I think a lot of this is like I think that's basically the precursor technology to a lot of these things. And the people who are actually coming up with these terms and inventing this stuff for the first time probably uh, were thinking were very familiar with record players, and a lot of these terminology possibly came from their familiarity with that sort of technology. So as time goes on and we're less familiar with record players, it becomes stranger and stranger vernacular. Um, and the perfect example of this is I know that this means save. A lot of people know that this means save, but imagine you're, 10 years old, 15 years old. Are you going to know that this means save? I mean, this is such a strange symbol to somebody who's not familiar with the A drive and with floppy disks and with the history of technology. It's the same thing with Git. If you're not familiar with turntables, that term head might really be hard to catch on to. All right, so now we're moving on to branching basics. Let's talk a little more about branches. Branches provide a way for you to keep separate streams of development apart. While this can be useful when you're working alone, it's almost essential when you're working on a team. Imagine that I'm working in a small team and have a feature to add to the project. While I'm working on it, I don't want to add my changes to master as it still doesn't work correctly and might mess up my team members. I could just wait to commit the changes until I'm completely finished, but that's not very safe and not always practical. So instead of working on master, I'll create a new branch. Okay, so git checkout -b, my new feature. Let's look at these commands. I'll probably run them. And let's look at them with Visual Studio opened. See if we can take advantage of any of the uh, the GUI features or anything like that. I actually never noticed this beaver here. It looks like there's a beaver on the desktop with the foot here, the tail here, a tooth and an eye, and then here's his back and his head. I never noticed that before. I kind of like that. All right, so let's open up this, and then we're going to go into my repo. We can see here if I do a git status, we're not inside of a Git repository. So in order to get the status of a Git repository, your present working directory has to be a Git repository, and in this case, it is not. Now, as you're working, and in the real world, if you're working with people who aren't really catching on to this, making mistakes, you could find yourself in a Git repository that's not the Git repository you were supposed to be in, or you could find yourself in a Git repository within a Git repository. In that case, things are just really difficult. To know whether or not something's a Git repository, the best way is to do this ls-a and look for the .git folder, and then do a git status afterwards and see the status of your repository. So yeah, it can get confusing, because if I were to do cd make mkdir example like this and then cd example, now I can do git init, and now I have an empty Git repository within a Git repository. So if I do a ls-a, I've got a .git here. If I do a cd ... ls-a, I've got another one. So I've got a Git repository within a Git repository, which is just a complete nightmare. So if I do a git status here, we can see I've got no commits, but if I do cd back git status, now I do have commits. So you can see just how confusing that could be. You could go work on a project somewhere, within your Git repository, do a Git status and say, well, where all the commits go? There's no commits. Well, it's because somebody, maybe yourself, initialized a Git repo within a Git repo. So you're seeing the status for that repo inside the repo. So just save yourself all that trouble. Don't put any repos inside of repos. Make sure that you're always creating a child folder for all of your projects, and you don't just have a parent folder with a Git repo, and then you make another child folder to that parent folder with the Git repo that has its own Git repo. Make sure that all your Git repos are their own repos without any extra Git repos within them. That's just a recipe for disaster. Okay, so rmdef example. Okay, and now we'll follow along with the shell commands here. So we've got the first one, git checkout -b, my new feature. So we did git checkout before. If we do a git, let's do a code dot so that we can get our Visual Studio up. Okay, and now if I bring up the terminal, yeah, so we can see what we were playing around with before, this version 2. If I do a git log one line with an E, I keep doing online, and then I do a git checkout, so I can move this head anywhere to these other ones. Let's move it down to the first one, and we'll see this disappear. We did that in the last video, but we'll just do it again here. Okay, so now this changed. The previous head position was here, but now we changed the head position down to here. So if I do a git log one line again, we can see we lost our history here because our head is checked out down there, and we can see this head is there. But as I showed before, you can go and find these if you look through the .git folder. And then it'll tell you here where you were before. So let's move back to that. Oops, that's the wrong hash. Okay, so now we've got all of our log statements that we had before back. We've got this version 2 back here. So that's git checkout. So let's look at the help for git checkout. And we can see switch branches or restore working tree files. So huh. All right. Well, you know what? Let's just ignore the help for now. It's a bit too much information. We'll just follow along and make a new branch. And we might be able to use. Let's see if we can use the GUI in the source control tab down here. So we'll do branch. We'll say. Yeah, so here's an interesting option here. Create branch from. So if we go down to branch and then go down to create branch from, uh, we'll say my new feature. Okay, so now we can select where we want to branch off from. So just because your head is positioned at a certain SHA doesn't mean that you have to branch from that SHA. You can branch off from any of those SHAs, even one that you're not on currently. So let's try branching off from the I think that's true. Okay, well, maybe that's not true because I only see one SHA listed here. I don't see multiple. I think that just confused me. I'm just going to do a escape there to get rid of that. I'm starting to get a little bit confused, so I want to kind of stay on Rails with the tutorial here. So let's just do a git checkout -b, my new feature. Okay, so now we switch to branch my new feature, and then we'll do a git status. Okay, so now we're on a branch, my new feature. We don't have any commits now, so if I do a git log one line with an E, I don't know why I can't include an E. We still have just those 3 commits we had before, but now we can see the head. It's still at this SHA, but now we've given it a label named my new feature. And originally, before we gave it a label, it was master. We used the -b. We used the -b option on the checkout command to tell Git we wanted it to create a new branch. As you can see above, running git status in our branch shows us that the branch name has indeed changed. Let's look at the log. So I already looked at the log. I looked at the shorthand version of it. So I don't see where it's changed for them. As I hope you expected, the log looks exactly the same. When you create a new branch, the new branch will start at the location you were at. In this case, we were at the top of master. So that's where the new branch starts. So for me, it didn't look exactly the same. We have this new text here that we didn't have before. For theirs, it looks like it does look exactly the same. So maybe the --1 line gives you some extra information, which is kind of funny because it's meant to abbreviate it down and take information out. So I'm kind of surprised that it's adding in information extra. Let's just do a regular git log without the 1 line. Okay, yeah, so we can see. Oh, no, we still have the same information here. So it looks like the example doesn't have the same kind of information I have. Maybe it's because I'm using a different OS version or something like that. But all right, let's just keep on going. Now let's work on that feature, make a change to the hello.py file and commit it. I'll show you the commands for review, but I'll stop showing you the output of the commands for things you've already seen. Okay, so they're going to stop showing the output of commands for things we've already seen. Okay, so we've got to make a change to the hello.py file, or the, oh, okay, so this is we're doing this as a diversion. We're not using the same files as they are. Let's just make a change to our app.py file. So we'll say this is the change I made. Perfect. And now in our version control, we can take a look at those changes. I like to do this every time before I commit. Just go over here, even if it's a simple change like this. I just like to see the working tree so that everything is nice and clean. There's a lot of psychological components to coding, I find, because it's just like so many things are like, just being able to notice it or not. And I like to kind of ground myself sometimes. Okay, so let's do a commit. So if we go here and we do commit, so before we do a commit though, we're going to have to stage it. So we can click the plus sign here to stage the changes. Okay, and now that we've changed it, so we can look at the working tree as well. Now it's index instead of a working tree, but you can still see that same diff. Okay, and now we can commit. So we'll add added code for feature X, or made a change. We'll say made a change for the Git real Python Git tutorial, and that's much better. Is to always make um, your messages relevant. Don't just blindly copy what you see in a tutorial. Make it relevant and really understand what's being taught. Oh, and it looks like we've got this warning here, or this information. Yeah, I wanna install the recommended extensions for Python, linting, debugging. So yeah, because right now you can see. Oh, it actually looks pretty nice right now. So I don't know. I don't know what this is about. I kind of don't want to install this, but I think it'll keep bothering me if I don't install it. So I will install it. Kind of a captive host, which is what one of the biggest criticism I have of IDEs, and why oftentimes I just prefer Notepad++ because I don't like being bothered when I'm trying to use a piece of software. So like if it keeps, like we've all been traumatized by browser pop-ups. So I definitely don't want a browser pop-up when I'm trying to code. Now, if you do git log, you'll see that our new commit is present. In my case, it has that SHA, but in your repo is very likely to have a different SHA. And by very likely, they mean very, very, very likely. Okay, but let's do a git log one line and look at our new commit. There we go. Now switch back to the master branch and look at the log. So git checkout master. All right, so we can see our log is quite a bit different. We've got only 3 commits now that we're on the master branch, where we had 4 commits when we were on the my new feature branch. The change we made while we were in the my new feature branch. So it's going to be missing from the master branch until we add it to the master branch. Is the new commit added for feature X there? No, it is not. Git has a built-in way to compare the state of 2 branches, so you don't have to work so hard. It's the show branch command. Here's what it looks like. Okay, this is new for me. This is a gap in my knowledge. So let's take a look at this command. Okay, so we can compare 2 branches. We'll compare my new feature with the master branch. So here we go. So my new feature, here's the, looks like the commit. The chart it generates is a little confusing at first. Yeah, I'm a bit confused by it. So let's walk through it in detail. First off, you can call the command by giving the name of 2 branches. In our case, that was my new feature and master. Yep. The first two lines of the output are the key to decoding the rest of the text. The first non-space character on each line is either an asterisk or a plus sign. In their case, it's an asterisk. In my case, it's a plus sign. Followed by the name of the branch. We use the same branch name, so the name of the branch is my new feature. And then the commit message for the most recent commit on the branch. The star character is used to indicate that the branch is currently checked out, while the um, exclamation point is used for all other branches. The character is in the column matching commits in the table below. Yeah, so we can see the difference between their output and my output. They're actually checked out on this my new feature branch. That's why they have an asterisk here. For me, I'm checked out on the master branch. So the my new feature branch has exclamation point because it's a branch that I'm not checked out to. If we look at the master branch, we've got the asterisk because this is the branch I'm checked out to. The third line is the separator. So here's a separator. So these two sections of the output are separated from one another. Starting on the fourth line, there are commits that are in one branch but not the other. In our case, this is pretty easy. There's one commit in my new feature that's not in master. You can see that on the fourth line. Notice how that line starts with a asterisk or a star in the first column. This is to indicate which branch this commit is in. Finally, the last line of output shows the first common commit for the two branches. This example is pretty easy. To make a better example, I've made it more interesting by adding a few more commits to my new feature and a few to master. It makes the output look like this. Okay, so we can see we've got the separator. We can see he's checked out to my new feature, made a commit there. So, oh, I see, I see. So we've got the separator here. So we've got output from presumably the first branch. So this is the output from the my new feature branch, the branch that he's checked out to. We know that because of this asterisk here. And we can see that on this branch, he has commit number 3 and commit number 4. So here's the separator between the two branches, my feature and master. So if we go down here and we look at master, which is not the one he's checked out to. He's checked out to my new feature. We've got commit number 4 for my new feature on there as well. Yeah, so we've got a different series of commits per branch. So that's kind of nice. You can see the chain of commits and how they differ across branches using the git show branch command. Now you can see that there are different commits in each branch. Note that the my new feature, I think that's a tilde 2 sign, is one of the commit selection methods I mentioned earlier. If you rather see the SHAs, you can have it show them by adding the -HA -name option to the command. Yeah, I'd rather see the SHAs. So that's good. That's good to know. I'm going to try adding that to mine. Okay, so now I've got SHAs. One thing I am a little bit confused about though is why there's not SHAs for this branch, why there's only SHAs shown after the separator. I don't really see an explanation for that. So I don't think it's that big of a deal. Let's just keep on going. Uh, this is really just to compare the chain of commits. So, um, okay. Now you've got a branch with a bunch of different commits on it. What do you do when you finally finish that feature and are ready to get it to the rest of your team? You merge it. There are three main ways to get commits from one branch to another: merging, rebasing, and cherry picking. We'll cover each of these in turn in the next sections. Perfect. Yeah, I'm only familiar with merging, so rebasing and cherry picking are absent. They're holes in my foundational knowledge of Git. So let's fill in those gaps, starting with merging. There's probably even gaps in my knowledge of merging. So merging is the simplest of the three to understand and use. When you do a merge, Git will create a new commit that combines the top SHAs of two branches if it needs to. If all of the commits in the other branches are ahead based on the top of the current branch, it will just do a fast forward merge and place those new commits on this branch. Let's back up to the point where our show branch output looked like this. Okay. Now we want to get, okay, so um, yeah, I'm not sure if I'm at that point right now or not. And of course, I'm using a little bit different files than they are. So let's just keep on going. Now we want to get that commit to be on master, check out master, and run the git merge command there. Okay, so that makes sense. So if we do the git show branch, we can see we've got an extra commit. And let me get rid of that flag. Oh, I wish this were, yeah. Okay. There, that's better. Oh, that's interesting. Okay, so we can see we're on the master branch. Let's switch over to the other branch. So git branch, and then my new feature. We'll do a get log. Oh, sorry, git checkout. Perfect. And now we'll do a get log. One line. Okay, and now you can see we've got an extra commit on this branch that we didn't have on the master branch. So let's go ahead and add this extra commit to the master branch. So the first thing we're gonna need to do is switch over to the master branch. And let's try to use this using this tool here. So, so let's try to switch. Okay, so we'll do checkout to, and then we'll check out to master. All right, and I wish it would like be more clear about. Oh, okay, so here it says we're on the master branch. That's not bad. We've also um, got this output. Yeah, we've got this output and then it's set to get here, so we can see. Um, okay. Huh. All right, but we're on the master branch now. We can see that here, that you just hit Control Enter to commit on master. Okay, so now let's try merging using this. So we're going to do git. Uh, Okay, merge branch. So we're going to merge the my new feature branch. Since we were on the branch master, we did a merge of the my new feature branch to us. You can see that this is a fast forward merge and which files were changed. Let's take a look at the log now. Okay, so now I've got 4 commits, and you can see my head is set to master. So back when my head was set to master before, I only had 3 commits. I changed my head over to uh, a new branch, my feature, um, and you can see we had an extra commit when I did that. So now after I added it, now that extra commit is now a part of master. And it'll even tell you which branch it came from. If we had made changes to master before we merged, Git would have created a new commit that was the combination of the changes from the 2 branches. One of the things Git is fairly good at is understanding the common ancestors of different branches and commonly automatically merging changes together. If the same section of code has been modified in both branches, Git can't figure out what to do. When this happens, it stops the merge partway through and gives you instructions for how to fix the issue. This is called a merge conflict. And merge conflicts, in my uh, mind, are usually game enders. Oftentimes, when there's a merge conflict, I find myself uh, just like having trouble resolving it. But the IDE really helps you kind of figure out how to resolve merge conflicts, I've found. So if you're using an IDE, you've got like a fighting chance. Looks like they're not going to go over merge conflicts, but that's fine. I would say a merge conflict is a major reason why you'd want to use something like Visual Studio Code because it'll really help you follow those instructions for fixing it, make it nice and clear. All right, next section is rebasing. Rebasing is similar to merging, but behaves a little differently. In a merge, if both branches have changes, then a new merge commit is created. In rebasing, Git will take the commits from one branch and replay them one at a time on the top of the other branch. I won't do a detailed demo of rebasing here because setting up a demo to show this is a bit tricky in text and because there is an excellent webpage that covers the topic well and that I'll reference at the end of this section. Oh, okay. Let me read that again. That kind of went over my head. Rebasing is similar to merging, but behaves a little differently. In a merge, if both branches have changes, then a new merge commit is created. In rebasing, Git will take the commits from one branch and replay them one at a time at the top of the other branch. So I'm a little bit confused here because isn't this rebasing? Because it's the same SHA. Like I thought there'd be a new SHA that would say that it's been merged. So I'm a little bit confused what that means there. But I'm just going to move on. I've never done any rebasing, anything like that professionally. I think it's really not that important to have a good grasp of that. Okay, so the next one is cherry picking. Cherry picking is another method for moving commits from one branch to another. Unlike merging or rebasing, with cherry picking, you specify exactly which commits you mean. The easiest way to do this is just specifying a single SHA. So git cherry pick there. This tells Git to take the changes that went into that SHA and apply them to the current branch. This feature can be very handy when you want a specific change, but not the entire branch that change was made on. Quick tip about branching. I can't leave this topic without recommending an excellent resource for learning about Git branches. Learn Git branching has a set of exercises using graphical representations of commits and branches to clearly explain the difference between merging, rebasing, and cherry picking. I highly recommend spending some time working through these exercises. Um, Shoot, I kind of want to switch over and do this now. You know what? I think I'm going to do that. So the next section is working with remote repos. But before that, let's get a better sense of Git branching. I've got about 20 minutes left. So hopefully we can finish this in 20 minutes. So welcome to Learn Git Branching. Interested in learning Git? Well, you've come to the right place. Learn Git Branching is the most visual and interactive way to learn Git on the web. You'll be challenged with exciting levels, given step-by-step demonstrations of powerful features, and maybe even have a bit of fun along the way. After this dialogue, you'll see the variety of levels we have to offer. If you're a beginner, just go ahead and start with the first. If you already know some Git basics, try some of our later, more challenging levels. You can see all the commands available with show commands in the terminal. PS, want to go straight to a sandbox next time? Check out this special link. PPS, GitHub has started naming the default branch main instead of master to migrate away from biased terminology. In accordance with this industry-wide movement, we have also updated Learn Git branching to use main instead of master in our lessons. This rename should be fairly consistent by now, but if you notice any errors, feel free to submit a PR or open an issue. Okay, I'm trying to get a better sense of why, but unfortunately, I don't really have a better sense. And it sounds like the only reason they chose the word main is because it's already got an MA in it. So I don't know if they just want it to be shorter. It's just master has too many characters in it and they want to truncate it. But in the tutorial, it said that um, there's an issue with bias. I, I, I wish I kind of understood that issue with bias a little bit better. But unfortunately, I don't see a good explanation of that. Oh, I see. I see. Oh, okay. That makes sense. So both Conservancy and the Git project are aware that the initial branch name master is offensive to some people, and we emphasize with those hurt by the use of the term. That makes a lot of sense to me. Like in a lot of places, especially the United States, with a history of slavery, um, using those kinds of terms could be uh, exclusionary and cause some people to really not be as interested. Like imagine like you know using a program that's name is your name sucks. I would not use the Gram sucks software if I had to. So using master, is um, okay. Yeah, that makes sense to me. I'm in huge support of those kinds of changes because, like, master is just kind of like it can be anything. It doesn't matter whether it's master. So these kind of win-win situations where it's like, okay, it's shorter, it's not offensive. Um, yeah, it's a lot of changes because people are used to using master, but um, it doesn't even tell you. It's not even an accurate term too, because it's like it's not the master branch. It's the main branch. Um, so it's like there's nothing like it doesn't have like slave branches or anything like that. So that's not even like the proper name for it. So okay, that cleared everything up for me. Um, that makes a lot of sense. I'm glad they're doing that because a lot of you know this the coding is all about people, and the more people that learn to code, um, the better code is going to be. So removing barriers to people wanting to participate in it is a good thing. All right, so let's go ahead and we're going to select a level here. Um, shoot. Okay. Well, let's just start with the easiest level. This might be a bit too much of a diversion for me. Okay, so I think we've got to make this chart. So let's do so right now we're on Git 1, so we'll do a Git status. If they don't see anything, do a Git commit. Okay, Git commit again. Okay, so it looks like all you've got to do is try to match the chart they give you by doing a sequence of Git commands. Come on, just let me. This is annoying. Okay, so all right, I think I'm done with this. So it looks like it could be a good thing for somebody to go and do, but for me, I just want to keep going here. And I've got about 10 minutes. Okay, so the next section is working with remote repos. All of the commands we've discussed up to this point work with only your local repo. They don't do any communication to a server or over the network. It turns out that there are only 4 major Git commands which actually talk to other remote repos: clone, fetch, pull, and push. That's it. Everything else is done on your local machine. Okay, to be completely accurate, there are other commands that talk to remotes, but they don't fall into the basic category. Let's look at each of these commands in turn. Clone. Oh man. No, sorry. It's just like that whole idea of like getting rid of the term master. It's like there's this is kind of a rant, but like there's like a culture in the United States that a lot of people would like kind of be offended by that and say that they're trying to be PC or politically correct by doing that, and they shouldn't do that. And I I'm kind of the like I don't agree with that. Like I really think you should try to use proper language and really be clear in what you're saying. And sometimes if you're not being careful to use like language that is more politically correct, and you're just using like coarse, blunt language, sometimes I just don't think that's as clear. Um, so it just kind of triggered moments in my life where like people have used, um, a, I guess specifically, I had a music teacher who wanted me to play certain passages feminine and certain passages masculine, and I just that was a huge kind of red flag for me, and I was like, I had another teacher before that I told, this teacher was like telling me to do that, and he's like, wait, what? Like that's a really strange way to say to play something, and it's not a politically correct way to say something too, and it's just confusing to me because especially a lot of the like I just don't have a clear sense of what is masculine and what is feminine. Um, so um, so yeah, this again, this is something I'm really kind of proud of the uh, coding community for doing. It's much more clear what they mean by it being the main branch than what they would mean by it being the master branch, especially since there's really no concept of like a slave mat branch to a master branch. It's just unclear, coarse, blunt language that just isn't very helpful. So kudos for them for going ahead and changing that, even though it does seem like it's called like it's a little bit extra work to get people to catch on to it, but well worth it in the end, in my opinion. All right, so the next one is Git Clone. Git Clone is the command you use when you have the address of a known repository and you want to make a local copy. For this example, let's use a small repo I have on my GitHub account, GitHub Playground. The GitHub page for that repo lives here. On that page, you will find a clone or download button, which gives you the universal resource. Uh, I think that's an L locator to use with the git clone command. If you copy that, you can then clone the repo here. And this is what I was talking about earlier, um, where you've got to be careful not to clone a Git repo within a Git repo. So if I were to just stay in my current present working directory, so let's go look at my current present working directory here using the command pwd. I would clone that down to this, which if I do an ls-a, or even just a git status, we can see this is a Git repo. So if I were to do that clone command here, I'd have a Git repo within a Git repo, and everything would be confusing and awful. So you want to make sure um, whenever you do that Git clone command, you get this error message here, not a Git repository. Otherwise, you'll have a Git repository in a Git repository. So whatever your present working directory is, you want to make sure it's not a Git repository when you clone a Git repository. Okay, but let's go ahead and clone this Git repository. I'm running out of time pretty fast here, but oops, and I can't. God, that's okay. I'll just type it out. It won't take too long. Um, hmm, that's interesting. I think I might have typed it incorrectly. So what is it? 80525 github.com getplayground.git. Did I do that right? GitHub playground.git. JIMA 80525 github-playground.git. Huh. Weird. Okay, so I guess this repo he's got here isn't like maybe this is an older tutorial or something. Oh, okay, yeah, it looks like he moved the link, so he broke the link he was using. This is actually the link to clone that repo. But I can't put it in my. Um, all right, so now you have a complete repository of that project on your local machine. I don't have it, I could get it, but let's just move on. This includes all of the commits and all of the branches ever made on it. Note this repo was used by some friends while they were learning Git. I copied or forked it from somewhere else. If you want to play with some other remote commands, you could create a new repo on GitHub and follow those same steps. You are welcome to fork the GitHub-Playground repo to your account and use that. Forking on GitHub is done by clicking the fork button in the UI. Okay, so I'm not going to do that. I am out of time, so thanks for watching and see you in the next video where we learn about fetching from remote Git repositories.